Alright, let's go ahead and continue our discussion of conditional probabilities by looking at independent and dependent events. Two events, E and F, are independent if the conditional probability of E given F is equal to the probability of E. So this means that having that extra assumption that F had occurred didn't change the probability of E occurring. So you are independent if the probability of an event doesn't change because it didn't depend on the probability of another event. If this equation is not true, then E and F are said to be dependent events. So if having the assumption of F changes the probability of E, then the two events are dependent. Even if it makes the probability of E less likely, it's still a dependent pair of events. So let's take a look at this example here. We have a survey of 100 psychology majors. 25 of them have taken economics, 35 have taken French, and 5 have taken both economics and French. Are the events had taken economics and had taken French independent or dependent? Okay, so let's see. Let's write down what we know. I'm going to use E for economics. Economics will be E, and French will be F. Okay. So the probability of taking an economics course, there were 25 out of 100 total. So this would be 25 out of 100, or if we simplify, that would be 1 in 4. Okay. Let's see. The probability of taking a French course, there were 35 out of 100 students. And so let's see. That would be 7 out of 20. 5 goes into 100 20 times, and 5 goes into 35 7 times. You don't have to simplify the fractions. You can leave them, as unsimplified fractions. And let's see, the next thing we have, 5 had taken both economics and French, so that's our intersection. So economics and French classes is 5 out of 100. And if we simplify, that would be 1 out of 20. Okay, so are the events had taken economics and had taken French independent or dependent? So you can check the probability of E given F, or you can check the probability of F given E. It doesn't matter which order you look at this. So I'm going to look at the probability of economics given that a student took a French class. And the question is this equal to the probability of taking an economics class? If the two are equal, then these pairs of events would be independent. If the two are not equal, then they are dependent. So let's see, the economics probability we already know. This is 1 in 4. So now we need to figure out the conditional probability. So let's go ahead and do that. The conditional probability, E given F, this is the probability of E intersect F divided by the probability of F. So let's see, the probability of both classes was 1 out of 20. And both classes is 1 out of 20, and we want to divide that by the probability of French class, which was 7 out of 20. And so let's see, simplifying the fractions, we have 1 out of 20 times 20 out of 7, because remember, division is multiplication by the reciprocal, and 20 divided by 20 is 1, and so we get 1 in 7. So what we have is that the probability of E is not equal to the probability of E given F. So these are not equal. And so that tells us that we have the second case. The two events are not independent, they are dependent. So had taken economics, so taking economics and taking French are dependent events in this case. Not independent. If the probabilities had come out to both be 1/4, then knowing that a student took French would not make them more or less likely to have taken economics. But in this case, if we know that a student has taken French, they are less likely to have also taken economics. And so that changes the probability of a student taking economics if we assume that they have also taken French. And so these would be dependent events because the probabilities change. If the probabilities did not change, then we would have independent events.